Okay, so let's say you want to nest an array. Like you got a big old array, like this one here, where we have, a bunch of things that are sort of at two different levels of capture, right? Like, I might have, act and scene, right? Like film play, right? So I could have, maybe I have two scenes in act one, and I have, one scene in act two, and then I'm going to have like another, another one down here, which is just going to be in Act Three. I'll also have a scene, right? And what I'm trying to do is I want to cluster them, right, so that all the scenes from a given act are together. But right now, what I've got is sort of just a big old flat array. So what I'm going to do is I want to group it by act, right? And I want the one array, which is going to give me basically a list of acts, and then for each act, you'll tell me what the scenes are that go along with it. And if I have a little bit of extra data, I don't care quite as much. What I really care about is just being able to associate the scenes with the proper acts. So let's start with that and ask what we can do with that. So the first thing we can do is find out what our list of acts are. And that can be that can seem like it's a little bit of a tricky thing. But there's actually a one-liner we can do, which is we create a new variable, we'll call it keys, which is going to be based on that array, just like we have here. And then we're going to run a get, because whatever you run a get on an array of objects and you pass it a single path, it creates an array of the values at that particular path, right? So what will happen here is if I ask for the input key using this get, it will pull the 1 and the 1 and the 2 and the 3. In fact, let me just illustrate that right now. I'm going to throw in a little stop and debug, always my favorite function here. And I'm going to say, tell me about keys, right? Okay, so let's run this for a second. And this keys 1, 1, 2, 3. Now, of course, these are duplicated, right? I'm just looking for a list of unique keys. And for that, we actually have another filter. It's called unsurprisingly unique, which gets the actual unique values. It has some more complexity in terms of its interface, where you can set a path for when you're dealing with, finding uniqueness in a list of objects. But if you're just looking like a list of numbers or a list of strings like we are right now, don't need to set that at all. You just use the unique filter. And the effect of it will be, if I run it again, hey, look, I just get the 1, 2, and 3, right? All my duplicates get taken away. So let's get rid of that. Great. So now I've got my list of keys. What I want to do is loop over all of these acts and find out where the scenes are, because it's actually no guarantee in terms of how this thing works. Ooh, I didn't mean to lose that. Great. So here we are with my list again. I had accidentally blipped it for a second. And what I want to do now is loop over those keys. We just talked about the 1, the 2, and the 3 to go find out what scenes actually go with them. So to do that, this is essentially a reducer, because we're going to produce a result that is going to be the different shape and a different number of keys than what we started with. So sometimes we talk about mapping, which is where we go over each element in an array. This is going to be a reducer, where we're going to produce something that is differently shaped than where we start. And to do that, we create a variable, which we call an accumulator, but I'm just calling it output right now, which is just going to be a blank array. And this is going to be my array of actually acts that I'm going to collect in here. And then for each act, right, so I'm looping over my keys are my acts, I'm going to just find out which of these elements are associated with my particular act. And I can do this again in a one-liner in Xano using the find all elements. And I can ask about the initial array and ask for which ones the key, right, which is at whatever path I specify key to be, is going to be, it is equal to whatever this item is. So for each element. So, first I'm going to be looking at act 1. I can compare act. I'm saying, okay, I'm starting with act equals 1, and this passes, this passes, this fails, right? And so this will produce for me this list of arrays, which is pretty handy to have. Now I've got my scene A and my scene B. And then I can put them, and I'm now collecting them into a list of what I'm just calling elements, for lack of a better term. And then I'm creating a sort of a wrapping object for it. That way I know what the key is going to be. That way I can just say I'm going to have a top level object that has an act of 1, and then it's going to have a member called elements. And of course, you probably want to change that name for whatever your business logic is going to be. But that's basically going to be each of the scenes that I have in here. Okay, and then having created that, I now have basically for Act 1, I have an object that contains both identifying it as Act 1 and then all the scenes it goes with. And I'm going to use array add to end to put this at the end of my output array. So far, so good, pretty easy. Ding, ding, ding. And then, and should loop through that for each of these acts and each of these scenes. So we can, and then at the end, we're just going to return output because that's what we're doing as a function here. So let's see how this works. Okay, so I have an array here, right? 3 elements in the array, 1 for each of the acts, Act 1, Act 2, Act 3. And then I have scene 1B, 2A, and 3A. Okay, so far that seems pretty encouraging. So what if we say we want to insert another Act 2, scene B, underneath all this? What if it comes in out of order? Does it still work? Well, let's see here. We'll compress that. And we'll say, okay, well, Act 1, 1. Act 2, A, B. Look, it collects Act 2 together, even though they weren't actually in the array together. And I think I can do something similar by putting an Act 3 thing at the beginning. So I will say this is going to be Act 3. And by the way, there's no particular reason that the acts have to be strings. They could be anything. And then I will say scene, and we'll say Z. Okay, cool. Let's try running that. Okay, now the cool thing is it actually picked up Act 3 first. So one of the things you'll find about the array that's getting generated is it is a little bit here at the mercy of in what order it finds the keys. Now, a thing we can do here is we can actually add another filter here, and we can just say we want to sort the array, and then yeah. So if we did this and we ran this, you see once again it gives me Act 1 first because I just made sure that I sorted the keys. So it goes 1, 2, 3 instead of how in the order in which you found them. And, throwing in these uniques and sorts and making use also of the looping around to create the reducer function, the finding all elements. These are all things that allow you to do very complex manipulation in Xano relatively tersely, which is great because often we wind up wanting to do more complicated things as we are dealing with data and want to deliver it back to the front end the way that the front end doesn't have to do as much work or as much thinking in order to get what it needs. This is the kind of hardest 5% work that we do all the time here on State Change, and I hope that you found it helpful.